Let's say I have a triangle, and I know that it's a right triangle. I know one of the angles is 90 degrees. What do I know about the other two angles? Well, I know that A and B, right, algebraically, they add up to 90 degrees. So we call them complementary angles. So given this, how can we figure out what A and B are based on the information that we have? We know that this angle is 90 degrees, but we don't know A and B. Now let's say we know the side lengths. I have A, I have the side that's next to A, I have the side that's touching A, we'll call that the adjacent side. And I have the side that's on the other side of A, we'll call that the opposite of A. And of course, in any right triangle, you have that diagonal line, we call that the hypotenuse. That's the longest line in any right triangle. Based on that, we can come up with some trigonometric ratios. They're basically ways that we define something about the angle based on the side lengths around it. For example, if I wanted to talk about A in terms of the opposite side divided by the hypotenuse, that ratio, we would call that the sine of A. We call it the sine of A because if you actually look at the graph of this, it goes up and down. It goes up and down. It's sort of like curving. If you look at the word sine in Latin, it comes from the word sinus, which literally means curve. It just means curve. So basically what happens is as the opposite gets bigger and bigger and bigger relative to the hypotenuse, they eventually get to the point where A gets extended so far that the opposite and the hypotenuse are the same length, and that's when when this angle is actually 90 degrees. Which, usually doesn't happen, but you can see how it approaches this value of 1. As the opposite gets bigger and bigger and bigger, right? If I draw a taller and taller triangle, right, you can see how this angle is getting bigger and bigger and bigger. Now, let's go back to this idea of complementary angles. If I want to figure out something else about A, well, what if I take the adjacent side and I divide it by the hypotenuse? So now I'm not seeing what happens as the triangle gets taller. I'm seeing what happens as the triangle gets longer. So for example, if the triangle is short, right, that angle is going to be different than if it is long, right? We can see the difference in that. So this angle, when we do this function where we do the adjacent divided by the hypotenuse, we call it the complement of sine. And why is that? Because the complement of sine adds with the sine to make 90 degrees, because A and B add up to 90 degrees. So the cosine of A is the length of the adjacent side divided by the hypotenuse. Okay. Now, let's say I don't want to worry about the hypotenuse. Let's say I don't know that information. What I can just do is compare the opposite side to the adjacent side. So if I divide the adjacent side of an angle and the opposite side of an angle by the adjacent side of that angle, I get something called the tangent of that angle. This name comes from the fact that most of these trigonometric functions are based on a circle, where the x coordinate is sort of like your cosine and your y is sort of like your sine. And so what happens is, let's say I make a triangle at this angle, the opposite over adjacent actually equals this angle here, the angle formed with the tangent of the line. So that's where the name of tangent comes from. So now we know our trigonometric functions. We have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. In other words, we can write this as an acronym and we call it SOHCAHTOA. So this is helpful for us remembering which functions map with which ratios. Let's look at a question here. Let's say I have a starting point and I fly a helicopter. I flew a helicopter up 20 meters and then forward 500 meters. What is the angle what is the angle between my starting point and my ending point? So I lift off, I go up 20 meters, and then I go up 500 to the right, forward. What would my angle be between my start point and my end point? So I don't know my hypotenuse here, so I can't really use sine and I can't really use cosine unless I do the Pythagorean theorem and find them out. Let's just use the information we have. If I look at angle A, which is the angle from my start point to my end point, I have a opposite of 500 meters and an adjacent side of 20 meters. So let's use that in our calculations. The tangent of A is opposite over adjacent, so it's 500 divided by 20. Well, we can just simplify that. The tangent of A is 25. Now, we're in a bit of a pickle here. How do I undo a tan function? I know how to undo a square. I just do the square root. I might know how to undo multiplying. I just divide. How do you undo a trigonometric function? On your calculator, you'll find something called arc, and then the name of the function, arc sine, arc cos, arc tan. You may also see this notation where it's sine or cos or tan raised to this -1. It doesn't actually mean 1 over tan. Don't write it like this. It's not a polynomial exponent. What it means is the tangent inverse. It basically undoes the tangent function. So I have tan of 25. This angle A equals, if I take the tan inverse of both sides, tan and tan inverse cancel out. So I have A, and then the tan inverse of 25, I'd write that down. So A is the tan inverse of 25. If I put that in my calculator, remembering that this is degrees, we want our answer in degrees. Ensure that that's the case on your calculator. So your answer is going to be, because we're talking about degrees, right? Angle in degrees. So 87.71 is my answer, rounded to 2 decimal places. Now, we can think about this answer before we actually write it down and think, okay, that makes sense. I'm only going up a very tiny amount, but I'm going forward quite a bit. So this angle is going to be really big. It's going to be almost 90 degrees. So it makes sense that it's pretty close to 90 degrees. Now we can write our therefore statement. So therefore, the angle between the helicopter's start point, which is over here, and its current position, which is over here, right, subtending the triangle, is 87.71 degrees. Okay? So that's how we use some trigonometric functions to answer some math problems in our everyday lives.